Good day once again. Welcome to today's class. In today's class, we'll be solving problems using the properties of the Riemann integral. We'll be solving problems using the properties of the Riemann integral. If you want to see the properties of the Riemann integral, you can go through the previous videos. I have a video on the properties of Riemann integral. You will see the properties there. But in today's class, we'll be making use of those properties in order to solve problems. We take the first one. It says we should evaluate the integral of 3dx from 2 to 6. Recall from the properties that when we integrate a constant over the interval a to b, it gives us the constant into b minus a. Therefore, the integral of 3dx over the interval 2, 6 will give us 3 into 6 minus 2, and that is 3 into 4, and that gives us 12. I'll take another example. It says, given that the integral of x squared dx from 0 to 3 is equal to 9. We are to do what? We are to evaluate the integral of minus 4x squared dx from 0 to 3. We are evaluating the integral of minus 4x squared dx from 0 to 3. This is the same thing as the integral of minus 4 into the integral of 0 to 3 of x squared dx. But you will remember that we have been told that in the integral of x squared dx from 0 to 3 is what? 9. That makes use of that property, which says, let's try to recall the property. What does the property say? It says if we are integrating c into f of x dx over the interval a to b, that it is what? We bring out the constant c into the integral of f of x dx over the interval ab. And that's what we have done here. We have our minus 4 out into the integral of x squared dx from 0 to 3. And this gives me what? Minus 4 into 9, and that is what? Minus 36. Given that, we take a third one, given that the integral of the square root of x dx from 4 to 9 is 38 over 3. We are told to evaluate the integral from 9 to 4 now of square root of x dx. Again, in order to do this, let's recall the property that we are going to make use of. Again, if you need to see the properties, I have a previous video on the properties of Riemann integral. It says the integral of f of x dx from A to B is equal to what? Minus the integral of the same f of x dx from B to A. From A to B will now become what? Minus from B to A. In this question, we are given the integral of root x dx from 4 to 9. We are told to evaluate the integral from 9 to 4. Therefore, the integral of sod x dx from 9 to 4 will be the negative integral of root x dx from 4 to 9. But we are told that from 4 to 9, the integral of square root of x dx is 38 over 3. This gives us what? Minus 38 over 3. Minus 38 over 3. Another example, remember we are looking at what? Solving problems using the properties of Riemann integral. Look at the fourth example. Evaluate the integral of x cubed plus 5x squared minus 3x plus 11 dx over the interval 3 to 3. But recall from our properties of Riemann integral that when we take the integral of f of x dx from A to A, it is what? 0. Therefore, the integral of this, since it is from 3 to 3, is still what? 0. The integral of x cubed plus 5x squared minus 3x plus 11 dx from 3 to 3 is what? Is 0. As simple as that. You want to look at the addition and subtraction rule in the properties of Riemann integral. The addition and subtraction property. Let's see how we make use of that in solving problems. That's the fifth one. Given that the integral of f of x dx from 1 to 3 is equal to 6, and the integral of g of x dx from the same 1 to 3 is equal to 10. We want to evaluate the integral of f of x plus g of x dx from 1 to 3. Recall that the integral of f of x plus g of x dx over the interval a to b is equal to the integral of f of x dx over the interval a to b plus the integral of g of x dx over the interval a to b. So the same thing will happen there. The integral of f of x plus g of x dx over the interval 1, 3 will equal to the integral of f of x dx over the interval 1 to 3 plus the integral of g of x dx over the interval 1 to 3. We are told that this is what? It is 6 plus what? Plus 10. And that gives us our answer to be 16. Take another example. Take another example. Just to show us how to make use of the properties of the Riemann integral in solving problems. How to make use of the properties of the Riemann integral in solving problems. It says, given that the integral of f of x dx from 3 to 7 is minus 2, and the integral of g of x dx from the same 3 to 7 is equal to 9. We are told to evaluate the integral from 3 to 7 of f of x minus g of x dx. I expect that we should be able to try our hands on this using the sample of the addition rule. Try your hands on that and leave your answer in the comment section. Try your hands on that and leave your answer in the comment section. Let's see a last one. It says, given that the integral of f of x dx from 2 to 9. Now let's be careful and let's be mindful of the interval is equal to 12, and the integral of f of x dx, the same f of x dx, over the interval 6 to 9 is equal to 7. We are told to evaluate. We want to evaluate the integral of f of x dx over the interval 2 to 6. Now recall, I'll rub this off. Recall that the integral of f of x dx over the interval a to b is equal to the integral of the same f of x dx over the interval a to c plus the integral of f of x dx over the interval c to b, where c is an element in AB. Our C is contained in AB. So does that apply here? I think it does. Let's look at the application there. The integral of f of x dx from 2 to 9 is equal to the integral of f of x dx from 2 to 6 plus the integral of the same f of x dx over the interval 6 to 9. In the question, we are told the integral of f of x dx over the interval 2 to 9 is what? 12. And then the integral of f of x dx over the interval 6 to 9 is what? 7. We are told to find the integral of f of x dx over the interval 2 to 6. This tells me that my integral of f of x dx over the interval 2 to 6 is equal to 12 minus 7, and that is 5. You can also try your hands on some other examples and leave your answer in the comment section. If you have benefited from this video at all, or if this video has been useful to you on solving problems using the properties of Riemann integral, give the video a thumbs up or a like, and you can share with your other colleagues so that they too can benefit from it. Have a beautiful day and God bless you.